Hey guys, so welcome. Today I'm going to talk about one of my recent project where I'm trying to build a machine learning system for a machine learning model where name entity recognition model. It will going to fine tune the model on public reviews data so that model will be able to recognize what all of the aspects mentioned in the reviews in the given reviews. However, the main goal of this project is for us to try to apply engineering practice in building a machine learning system instead of focusing too much on the model accuracy. So I hope you enjoy this video. All right. So let's start with some like architecture of what is going to happen here. We can go with this like that is the main architecture diagram. um, we can start with like being a data scientist like this one. Give me 1 second. Okay, so it is assuming that we are a data scientist. We are going to develop our model in our Jupyter notebook, and then we when actually we're going to do it now, but I'm not going to walk through all of it, but instead I'm trying to run the whole notebook because it will take a while, and while it is running I also like sharing a little bit more about it. So we will actually let's do something new over here. No, might not need it. Restart and run all kernel. All right, so the first thing is that this model is trying to load the dataset from Hugging Face. You can see here, this is my custom Hugging Face dataset that I uploaded earlier. It contains some data, validation, and also a test dataset. We are going to understand a little bit about the data, tokenizing it, preparing to be inputted into the machine learning model, the fine-tuning process. So here is where we define the fine-tune the fine-tune model. So a little bit I will go over this very quickly. All right, so here is the training loop. We evaluate and log it on MLflow. As you can see here, we set something regarding to MLflow. So if you don't know, MLflow is a tracking more like a facilitator for machine learning workflow, where we can run experiment, track our experiment results, parameters, and most importantly our models inside MLflow, so that later we can deploy it. We can deploy it from MLflow. So here we are going to run the training. As you can see, it is already training now. And finally, after training, we'll try to load the model to do some kind of inference. So while we are waiting for the model to train, we are going back to the diagram to talk a little bit more about it. So let's say that we are data scientists. We develop our Jupyter book tracking experiments, and yes, experiment artifacts is logged into the MLflow, which is hosted into in our GKE cluster. Let's say that we are happy with it and we want to like push the model for review. We can do that like we can do that by sorry, step back a little bit. Before we can actually push the model for review, let's say that we are going to wrap the model. Let's say there are some changes in how we define the API services. Maybe we load a new parameters into the API service, so we actually will make changes to our API. So the API here is the wrapper around our model, which will be a service that listen to requests and returns the machine learning predictions as results. So let's say that we're running the Jupyter notebook here. We get a new model on MLflow, but after that we will build an API service. So we will use ML server to as our API framework. because it is designed for ML, so there are some features that we can benefit from it. um, what it actually does is ML server will load the model, store in model registry into it memory, and then it will spawn up some UV-cone instance to listen to request. After we do that, we containerize the ML server with Docker and push the image into Docker Hub. Uh, After all that is done, we can finally push our code into GitHub, and because we have already linked GitHub with Jenkins, Jenkins will be notified of the new commit in our repository, and from that it will actually starting some building, and we will go into that a little bit later. But Jenkins will actually start some, not really start some build process, but it will actually prepare some build, and here it will actually ask for some of the manual instruction into whether to proceed or not. And the reason is that normally we would, after we push our code, we will ask our supervisor to review it, and then only when it's approved, and then we can deploy the new model and then merge the code into the main branch. For that, here let's assume that there is a data scientist lead here, so she will review it, review the model, review the pull request, and maybe going over to MLflow to see artifacts and experiment as well. And he can actually from that interface. So let's see. All right, so the training is already done. Oops, there are some mistake over here, but never mind. Just get going on. Oh, because the new model training, it doesn't return anything of here interesting, but let's say that we are okay with that. We should be able to see new experiment in MLflow right now. So go back to experiment. Here is our, yep, so 5 minutes ago we trained a new model log here. All right, so let's say that the data scientist lead, she review everything, and she will approve it to be the new model. She will do it here. She will register new model, the existing model. So after registering, we expect to see a new version 2 over here, and version 2 and version 1. You see that the version 1 is tagged as champion. So champion here denote that it's just like an alias, but this will be kind of alias that we use to serve the model. Only the champion model will be served to end users. So now, since we want the version 2 to be the champion, to be the one who served in the request, we will adding the champion here. All right, so it is already changed to version number 2. All right, so this step is done. We already labeled new model as champions. Now all right, we haven't pushed any new code into to GitHub, so let's do that now. Going back to our code base. Where is it? So here is our code. Let's see. Okay, there are some changes in our notebook. Okay, we can do that. We can push it's a slide to save some time. We are not going to create a new branch, but just like a new model, new better, way better model. All right, so we are going to sync the change, push the change with a new commit to GitHub. Give it a little bit, and then we are going to Jenkins, because we are expecting Jenkins to identify some new changes. It's already did. Yep, it's already did. So there is a new build pending here, and it's starting building already. So let's see. It is very basic Jenkins file. I did not do anything sophisticated here. Yeah, but in the meanwhile, while waiting for the build to get ready, let's take a look at a little bit of the Jenkins files. So yep, here is the Jenkins files. So the Jenkins file, there are three stages. The first one, we're trying to just to test our connection to Kubernetes, making sure that we have the necessary credential to get access to our target cluster. We will ask the user. The Jenkins will stay here and wait for menu instruction before proceed and deploy with just like annotating the new our inference service with just the current data, so that it will reload the change based on new configurations. All right, probably the Jenkins has already been loaded. Yep, so you can see proceed or abort here. Here we can see all the namespaces in our GKE as well. So let's do a proceed. Let's proceed with it. Okay, it's already applied a new configurations. Let's go back a bit. Sorry, let's go back a bit on to our model. So here let's check things out. 1 second. Let's check things out. So take a little bit for us to connecting to it's here. So you notice something something here. So here is where our ML server, the port containing our ML server is running. This is the old revision 16. We have just deployed a new revision 17, but it is in pending stage. Okay, let's see what happened. We will actually describe. You can see that. All right, so it try GKE, the control plane of our Kubernetes cluster, realize that we don't have any capacity left in our existing 3 nodes. Okay, so what it did is that it triggers a scale up. So we will have one more node, which is this name GRP at the end. Wait a bit, so we'll see whether the node is all right. So we already see that there is a new node here for this 3 seconds ago that added to the cluster. Now we going back here. All right, so we are see that from pending the steady chain from to continue creating. Let's give it some time, maybe give it some time to load itself. In the meanwhile, we can also take another look at our cluster resource. Here I have the Grafana dashboard over here, so let's reload it. Yep, previously we had 3, but now there is a new node here, and yep, there is a new node here. There are a lot of the things, the details in the dashboard, but it is, yeah, basically we have a Grafana dashboard to monitor our resource. The thing I care most about is actually the CPU request, the RAM request, because like this will actually affect the scaling and affect the allocating of new port onto new nodes. All right, let's go back to see if our service actually up. Okay, so you have seen previously we have 16 running, but it's already terminated. Now we have already 17 running. It is running right now, and right, let's make some inference. Let's test inference to see this. Okay, with me here we can have a test inference. Should I expect to see something? Yep, we already have the results here for the API, and we should also expect to get the result in Drager, because we have this component in our GDE as well. Let's file tray again. We have a few seconds ago a new trace where we have identified that, well, of course 99% of the time spending in the predict section. Okay, so Yep, so basically that's it. I think I have demo the the full flow of like of my current application ML system right now. There are a lot to improve, but yeah, this is the very first step, and I look forward to to adding more to this series. um, yep, so actually the service is exposed here in this endpoint. And one interesting thing is that we have when deploying model with ML server, we have the documentations. So let some kind of Swagger doc already available for us. Let's try to visit it. Yep, here it is, the documentation. The Swagger is a nice thing about um, yep, about ML server. All right. Finally, I think since the project is mainly about building or applying building infras and components connecting to each other, it's gonna be helpful to look into this instruction. So this is where I document all of my GKE instructions along the way of creating this project. It takes like most of my time, and yeah, here are the detailed instructions. And of course, I'll be welcoming any suggestions or comments to make it better. So thanks a lot, and see you again.